All right, here's our quick summary on what we learned about constant velocity. So the first thing we notice is that we can actually represent positions with dots, and we call this dot diagrams. And if they are evenly spaced, that means the position changes by the same amount every time. Of course, changes in position are displacement, and if that happens an amount of times, that is then velocity. So we can determine if it's constant velocity or not with dot diagrams, but the big one is our position versus time graph. So it has to be a position versus time graph, and I won't always write out position. I'll put x, that represents position in the x component. Giveaway is that the units are meters. And then time, of course, is t with units of seconds. An easy way to figure out if it's constant velocity is you'll have a linear slope. If it's linear, you've learned in math class that you can actually calculate the slope of an object by doing rise over run. All right. This isn't really physics specific though, so in physics we actually apply the types of measurements that are on our y-axis and x. So after I kind of analyze, hey, the change in the y component, which is position, I can then actually apply that down here. All right, so don't get that confused with x component. That is actually representing change in position because it's on the y-axis. You can call it change in position, or you could actually call it displacement because that is the definition of displacement. The change in the x-axis, well, time is being measured down here, so it should then be over a change in time. Knowing your vocab is a big deal. The definition of velocity is change in position over time, or again, you could say displacement over time. So the whole reason we did the graph was to then determine, well, this actually is velocity, and this formed an equation for us. Do be mindful that this equation, I'm going to outline it because it's a big one. This is only applied when it's constant velocity. Okay? And this is what we can use to solve for the velocity of an object if it's constant, if we know two data points on the graph. Of course, I didn't give us numbers here because I wanted to keep this quick, and we can talk about that later. All right, so if I ever ask you for the velocity of an object given a position versus time graph, find two data points, take the slope with those. Remember, it's got to be a change in the y and a change in the x, so that's why you need two. All right, like I said here, slope of this position versus time graph is always velocity, so that's something you want to start practicing. Repetition will help you memorize that. The last thing then is, well, there is another way to think about graphs in math class, the y-intercept formula. It is actually the same formula as this slope one, it's just rearranged differently. Okay, y equals mx y equals mx plus b is clearly the formula. M stands for slope, b stands for y-intercept, x of course what's measured on the x-axis, and y on the y. If you then apply again our measurements of position and time, it actually then becomes not just a random y-axis value, it's what's actually measured on the y-axis, which again is position. We call this final position, this y value. All right? M stands for slope. We've already previously said that, hey, slope is the velocity, so I replaced it with v. X represents the time that's passed, so I did change in time. And then B is the y-intercept, which again, position's measured on the y-axis, but y-intercept actually would represent the initial position because it's the first position given time passing. So this is actually then a rearrangement of, again, this slope formula, but this can kind of be useful if you're trying to solve for specifics, like what final position would they then meet at, okay? One thing I then want us to obviously look at is scenarios. So if you look at the slide in the PowerPoint, you'll notice that there can be more than one object in a graph. So my apologies, of course, that the background turned to black and the text is black. Also apologies for the shadows. I'm doing this at night on the notes that I did. But anyway, I have bullet points there with two questions within them where you guys can actually use these two formulas to not only calculate the slope of the objects by finding two data points and doing the slope formula, but then knowing that slope, which is the velocity, then you can apply it to the y-intercept formula for multiple objects and try to solve for things. All right, so give these two a good shot. Of course, I'll be there to help you guys out if you get stuck, okay? Good luck, everybody.